Hello students, let us solve a problem from NEET UG Paper 2021. Here is the problem. The problem states that from a circular ring of mass capital M and radius capital R, an arc corresponding to a 90-degree sector is removed. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring and perpendicular to the plane of the ring is k times mr square. Then you have to find out the value of k. So first of all, let us understand the problem once again. Suppose there is a ring which has capital M mass and radius capital R. A sector corresponding to 90 degree, that means this portion is removed. This portion is removed. And then the moment of inertia of the remaining portion about an axis passing through the center of the ring and perpendicular to the plane of the ring is given as I is equal to k times mr square. You have to find out the value of k. So this is very simple problem. What you have to do, you have to find out the moment of inertia of this removed sector, and we know the moment of inertia of a whole ring about its own axis as mr square. This is very well known result. So let us say that is I1, that is equal to mr square. Now if we can find out the moment of inertia of this removed sector, then we can subtract that moment of inertia from the moment of inertia of the whole ring to find out the value of moment of inertia of the remaining portion, and that can be compared with this given value to find out the value of k. So we know the moment of inertia of the full ring as this, and let us now find out the moment of inertia of this removed sector, and that can be written as I2 is equal to r square dm. Since this is a ring, it has a mass distribution at the periphery, so that's why we can write this as r square into dm, where dm is the mass of this removed sector. And how to find out dm? Dm can be found out if you know the mass per unit length into the length of this sector. Suppose that is dl, and mass per unit length is lambda. So dm can be written as mass per unit length lambda into dl, where mass per unit length is m by 2 pi r. That means the total mass divided by total length of the arc, the whole circular arc. So that is m by 2 pi r. That means this is the perimeter, and this dl is the length of this particular sector, and that is found to be pi by 2. So upon simplification we get dm is equal to m by 4. Now if we plug this into here in equation 2, then we get the moment of inertia of the removed sector as m by 4 into r square. Now what is the moment of inertia of the remaining part? We have to just subtract this I2 from I1 to get that. So the moment of inertia of the remaining part of the ring is found to be I1 minus I2 is equal to 3 by 4 mr square, and in the problem it is given as k into mr square. Upon comparing these two equations, we can find that the value of k is 3 by 4, and hence first option will be the correct answer for this question.